Okay, page 8. Let's do this first because we do need eccentricity as part of the conic section from now on. All right. What does the word eccentric mean? When you say, that was eccentric experience.
It's me.
Weird.
That's me, Michelle.
That's you? Okay, what does that mean?
It means C over A.
Oh, it does mean C over A, but what does the word eccentric mean?
Weird. Like crazy.
Like, huh?
Within a regular plane.
Outgoing?
No, that's interesting.
Could be
Like
outgoing.
Energetic, crazy.
Like acting weird.
The Joker.
It means you're different from what the normal is. Okay, so eccentric usually means different, right? So it's just different from what what usually is the norm. So eccentricity means how far you are from the norm. Okay, so eccentricity equation, we talked about this yesterday, is C over A. Okay, and so what we want to do is look at C over A. So eventually you have to kind of memorize this. E is a measure of how far you are from what the norm is or what it should be. So when E is equal to 0, John, are you with us? Okay. When E is 0, it is a circle, so it describes a circle. When E is a number that's between 0 and 1, it's going to describe an ellipse. When E is 1, it's a parabola. And then when E is greater than 1, it's a hyperbola. So then eventually we have to memorize this. For now, just know that E is just a measure of how far you are from where it should be. Yes? Very narrow hyperbola. I'm not really sure. Yeah, that's a great question. I'm not really sure. So we'll probably have to look at those cases and see what E will be equal to. It should still be more than 1. It's just maybe that number is a little different. Like really, really close to 1 or really far from 1. I think that's what happens. Okay, so let's look at hyperbola. Okay, let's label everything we know about a hyperbola. Okay, first, center. This center happens to be at 0, 0, but it doesn't have to be. Okay, and then we have 2 points that's on the edge of the hyperbola. We call those vertices. And then we have points that's inside the hyperbola, and we call them the foci for plural, focus for singular. There are no covertices on hyperbola. The next thing is the ABC. The ABC is a little bit tricky because it has to do with the axis. Okay, from the vertex to the vertex, this we call the transverse axis. Transverse axis. So there is no more major axis and minor axis. This is the transverse axis. T-R-A-N-S-V-E-R-S-E, if you can't read my handwriting. Okay, transverse axis. There is another axis that goes the other way, but it's really hard to see. So this is how you do it. Before then, let's talk about these dotted lines. What are these dotted lines called? Oh, you guys are so good. They are called asymptotes, and there are 2. So there are 2 asymptotes on the hyperbola because something will make it undefined. Okay, now to find the other axis that goes the other way, this is how you do it. You have to start from the vertex and then go to the right, hit the asymptote, and then do the same on the other side. Okay, start from the vertex, go left and right and hit the asymptotes, and do the same with the one on the bottom. And then we are going to connect the top and the bottom. So that's going to create a box. Do you guys remember this from last year, creating this box? Okay, so what you do is you create a box using the vertex to the asymptotes and then connecting the two asymptotes. This is going to create a box, and notice how your asymptotes are going to go through the corners of the box. Okay, the asymptotes go through the corners of the box and then also through the center of the hyperbola. The conjugate axis, which is the axis that goes the other direction, is the width of that box. So this is called the conjugate axis. Okay, again, conjugate axis goes the other way, and the only way you can find it is if you draw that box from the asymptotes. So we'll practice getting from the box to the asymptotes and then from the asymptote back to the box. Okay, let's talk about ABC. Where is A? The length from where to where?
It's the traverse axis. Is it the traverse axis?
Transverse? Yeah, it's the half of the transverse axis, which is from the center to the vertex. From the center to the vertex is A. Center to the vertex is A. Which part is B? B is a little bit hard to.
This one, conjugate, half of the conjugate.
Half of the conjugate, so from the center to the edge of the box. Yeah, it's getting messy. How about C? C is easier.
Yeah, that focus.
Yeah, so from the center to the focus. Go down this way. Center to the focus. All right, let's have you guys label the one on the right. You're gonna label center, vertices, focus, and then A, B, C. Okay, so center is center. These two are the vertices. These two that's inside, they are the focus or foci. A is from the center to the vertex. B is a little bit hard to see. You're going to have to draw that box. Okay, so B is this length, and then C is the length to the focus. All right, let's talk about the standard form equation of hyperbola. Okay, so let's, did you guys finish copying this down? Or double checking? Okay, so let's talk about the hyperbola on the left first. All right, standard form of a hyperbola is a little bit tricky, so kind of remove what you remember from ellipse, because it is not anything similar to ellipse. First of all, if you look at this hyperbola, ask yourself, which direction is the hyperbola opening? Up and down, or left and right? Up and down. So then, is that X direction or Y direction? Yes, people are like falling asleep. Come back. Okay, Y direction. Robin, that's you're zoning out. Yeah, I know, you're zoning out. Okay, so Y has to come first. So Y minus K. Okay, so whichever direction is the hyperbola opening, it has to come first. So Y minus K squared. And then there's a minus. So hyperbolas have a minus, not a plus. And then H minus, not H, X minus H. Okay, yeah, and then equals 1. Next thing, A squared and B squared. This is a little bit tricky. For hyperbola, A squared always comes first. Basically, it's whatever is opening up. The one that's opening, the one that has the hyperbola opening to it has the A squared. right? It's going up and down in the y direction, so y direction has a squared. If it's going left and right, then x direction has the a squared. Okay? Or just remember a squared comes first. All right, let's look at everything else on this hyperbola. Where is the center? HK, very good. How long is the transverse axis? Yeah, 2A. And then how long is the conjugate axis? 2B. How long is the semi-transverse axis? A. And then semi-conjugate? Very good. Vertices, do you guys think you can do this without me helping you? I think so. Okay, what is the vertices? So ask yourself, do you go up and down or do you go left and right?
Oh, yeah.
Up and down, so then do you move H or K?
K.
K by how much? A, yeah.
Oh, versus. I thought
Okay, and then same thing with the foci. Foci is always on the same line of axis as the vertices. Okay, so that is HK plus minus C. All right, asymptote is a little bit tricky. Asymptotes. What shape are these asymptotes? They're lines, right? So lines always end in the equation of y equals mx plus b, right? That's just a standard line equation. Now, instead of mx plus b, we are going to change it so that it's a m and then x minus h plus k. Because that's the standard transformation equation, right? X minus h plus k. And then we can square it, we can cube it, we can square root it, or whatever we want, but it's always x minus h plus k. The question is, what is the slope? All right, so let's look at one of these equations, or one of these lines. Let's look at this diagonal line that is sloping up, has a positive slope. What is the slope? So talk to your partner, what is the slope on this line? This diagonal line. Talk to your partner, what is the slope on this line? What is the slope on this line in terms of ABC? In terms of ABC. Not the numbers. ABC. Okay, what is the rise over run?
A over B.
A over B, very good. So you can see that it's going to go up A over B. So then that slope is A over B. Now there are two asymptotes, right? There is one that goes up and then one that goes down. What is the slope of this one that goes down? Negative A over B. So we're going to go down A over B. So basically the slope is A over B, and then it's going to be positive for the one that's positive, negative for the one that points down. So the slope is really A over B. But since we have two of them, it's going to be plus minus. Yeah, correct. Okay, relationship of C to A and B. So C squared, this one is a little different. A squared plus B squared, not minus. Yeah, so you almost want to just remove everything you know about the ellipse so you don't get confused. Last part, eccentricity.
C over A.
C over A. All right, everything on the other hyperbola is exactly the same, so I want you to just write the standard form equation, what you think that standard form equation will look like. All right, the answer is x minus h squared over a squared minus y minus k squared over b squared equals 1. Oops. All right, let's solve problems.
What happens if you accidentally put it backwards?
You mean you put a negative y minus k squared over b squared?
You said like y minus k squared over b squared minus x minus h squared over a squared.
So whichever one is positive is the direction it's gonna open.
Okay. Even if it's like smaller?
Even if it's smaller. So it's A doesn't mean it's bigger. Okay. Find the equation of the hyperbola with foci 0, -3, and 0, 3, whose conjugate axis has a length of 4. All right, draw the hyperbola. Go ahead and draw it. Okay, so the foci are 0, 3, and 0, -3. All right, so go ahead and show me with your arms which direction is the hyperbola going to open.
It's like this.
Up and down. Yeah, up and down, because that's where the foci are. All right, so HK, ABC. Okay, what is HK?
0, 0,
0, 0. A, we don't know. What's B?
We don't.
We do 2, because the conjugate axis is 4. Yeah. So how long is C?
3.
3. Okay, C squared is equal to what?
A squared plus B squared.
A squared plus B squared. All right, go ahead and find A, and then once you do that, write the equation. Maybe I'll help you write the equation. Okay, so 9 is equal to A squared plus 4. So A is square root 5. All right, now writing the equation, it matters which one comes first, right? So is X going to come first, or is Y going to come first?
Nice, got it.
Okay, why is Y going to come first?
So figure it down.
Because it goes up and down. Very good. All right, so Y minus 0 squared over what? 5. A always comes first. Okay, so over 5. And then minus X minus 0 squared over 4 equals 1. Okay. And then we can clean it up if we want, just to get rid of the zeros. Good? Okay, let's try one. So you and your partner do this one together, because this one has a slope of the asymptote, so it's a little bit tricky. Make sure you know exactly which direction it's going to open. Okay, these 2 points that they give you, what do they actually mean? What does it mean by endpoints on the transverse axis?
It's the vertices.
Yes, they are the vertices. So then that means your hyperbola is going to go up and down like that, right?
Yeah.
Okay. One of the asymptote is 4 over 3. Well, this 4 over 3, is it going to be A over B or B over A?
A over B.
A over B, because you can see that up and down is going to be A, right? So A over B. So 4 over 3 is A over B. All right, so from this point, you should try to find HK and then A, B, C. You don't even need C because they don't want the focus. So you just need A and B and then figure out where the center is. Okay, in this equation, A is not 4, B is not 3. The ratio of A to B is 4 over 3. You should try to figure out what A is by looking at the graph. Okay, first of all, where is the center?
2.5.
Negative 2.
Huh? 2.5.
2.5. Let me double check. Yes, negative 2, 2.5. So then how long is A?
3.
Huh? 4.5?
That's what I
Yes. So then A is not 4. Okay? The ratio of A to B is 4 over 3. You actually have to calculate B. Because it's the half of the length of this. So from negative 2 to 7, this whole thing is 9. So then half of it is 4.5. So this is tricky. 4 over 3 is not A and B. All right. B is it's not a perfect number. B is 3.375. And then C, we don't really care because it's not going to be part of the equation. Okay, so it's going to be y minus 2.5 squared over 20.25 minus x plus 2 squared over 11.39 about, and then equals 1. All right, so this is the kind where they give you some information, you had to find the equation. We're going to go backwards. Let's do the harder one. Okay, complete the square.
No.
It's not that bad, right? There's like a system to it.
Makes sense.
Okay, so complete a square. This one has nice numbers, so it's not too bad. And then you need to find the vertices and the foci. Okay, once you complete the square, let me check it. Once you have the standard form, let me check it. All right, let me make sure that everyone has completed the square correctly. So it's x minus 2 squared over 4 minus y minus 1. A lot of you put plus 1. Over 9 equals 1. Okay, so please be careful with the minus 1. Now, which direction will this hyperbola open?
That.
Left and right. Okay, left and right, which means you need to find the vertices by moving h and not k. All right, so hk is 2, 1. A is 2, B is 3, and then C is going to be square root 13. All right, go ahead and figure out the vertices and the foci. All right, so the vertices are 4, 1, and 0, 1. And the foci are going to be 2 plus minus square root 13, comma 1.